So this is the 36th session on relative velocity. This is in continuation of the 35th session. This is in continuation of the 35th session. So in this problem, in this video, this session, we'll discuss one more problem on phase B of phase 1. So before going, those who are new, you should not see this video first. Before going through 36, you must see the videos 35 and 34. Then only you should come to 36. All right. So before going, if you first take this one, that will not be proper, right? First you 34th you see, 35th you see, then you come to it. All right. So we discuss the 36th session on relative velocity. We take one more problem on phase B of phase 1. Okay, non-simultaneous projection. So numerical question on phase B of phase 1 that is non-simultaneous projection. Fine. So I'll write down the question. Here. Fine. Two shells S1 and S2 are fired from ground from point O with same initial speed V0 in same vertical plane at angles of projection theta 1 and theta 2 with the horizontal respectively. Shell S2 is fired t seconds after firing S1. T seconds after firing S1. Subsequently, the two shells collide in midair. Find the value of T in terms of V0, theta 1, theta 2 and G. Small g as usual denotes the free fall acceleration. Small g is just the free fall acceleration. Fine. So I'll rub it, okay? So this will be the second numerical question on phase B of phase 1. Fine. So I'll first draw the diagram. Okay. So in this case again there are three events. Event 1. Shell S1 is fired from ground, say at time 0, t equal to 0. say. Then event 2 takes place. S2 is fired from ground from same point O in same vertical plane with same initial speed at t barabar capital T, which is given. Okay. And third event, S2 and S1 collide in midair. S2 and S1 collide in midair at t बराबर capital T1 से. Alright. These are the three events which are taking place. First event, S1 is fired from ground at t बराबर 0. Second event, S2 is fired from ground at t बराबर capital T. Third event, S2 and S1 collide in mid-air at t बराबर T1 से. Now we have to determine the value of capital T. Now see, first of all, consider the time interval 0 to capital T. In 0 to capital T, S1 has already been fired, strictly more than 0. S1 in 0 to capital T, S1 has already been fired. Okay, so acceleration of S1 with respect to ground is g in downward direction, and acceleration of S2 with respect to ground is 0 because it has not yet been fired, it is just lying on the ground. So that meaning in 0 to t, relative acceleration of S2 with respect to S1 in ground frame is 0 minus g, which is non-zero. This is non-zero, meaning relative velocity is not constant in the time interval 0 to capital T second. But if we take the time interval t more than equal to capital T and less than t1 second, t is less than t1 and more than equal to capital T. T is less than t1 and more than equal to what? Capital T. In this interval, capital T to t1, both the shells are in air. Both are in air. That meaning acceleration of S1 with respect to ground and acceleration of S2 with respect to ground both are g in downward direction constant. We are assuming ideal case, no effect of air resistance, no effect of buoyancy of air, no effect of Earth's rotation, etc., etc. Only gravitational forces acting. Acceleration of both the shells are g in downward direction, g taken to be uniform. S1g, S2g is g in downward direction. That meaning, again we are observing S2 from S1. That meaning AS2 S1g is vector g minus vector g. It is it is just equal to AS2g minus AS1g. That is vector g minus vector g, that is 0 for all t belonging to this interval, capital T and capital T1. So this means in this time interval, relative acceleration is 0 throughout. That meaning relative velocity of S1 with S2 with respect to S1 in ground frame is constant. And if this value is constant, its value is same as the relative velocity between S2 and S1 at t barabar t at the start of the time interval. That is just equal to u relative. That is just equal to u relative velocity between S2 and S1 in ground frame at the start of this time interval. That is at t बराबर capital T. That is at t बराबर कितना? Capital T. That is at t बराबर कितना बोलिए? Capital T. Fine. That is at t बराबर कितना बोलिए? Capital T. So one more thing. So at capital T, the relative velocity between these is again same throughout this time interval. Alright. So relative velocity between these two shells in ground frame is constant in this time interval and is equal to the relative velocity at the start of this time interval, that is at t barabar capital T. It is just the relative velocity at the start of the time interval at t barabar what? Capital T. The relative velocity at this instant is also the relative velocity at every instant of this interval. Alright. Now I would have here, okay. So one more thing, what does the relative velocity constant imply? One other thing, with respect to S1, S2 will move in a straight path. With respect to S1, S2 moves in a straight path towards S1. In which time interval? In the time interval t to t1. Now one more thing, they collide at t without t1, and in t equal to in this time interval, s with respect to s1, s2 moves in a straight path, and they also collide at t without t1. So this means in this time interval, s1 will observe that s2 moves in a straight path directed towards s1. S1 will observe that S2 moves in a straight path. S2 moves in a क्या? S1 will observe that S2 moves in a straight path directed towards S1. Now we can rub this. So in this interval we can apply the formula y1 by x1 equal to u relative y by u relative x. So all these quantities are at the start of this time interval, that is a t block capital T. Only we have to determine these quantities, 4 quantities at this instant, and substitute in this formula, we'll get capital T. Alright. Now how to determine these quantities? So all these 4 quantities are at t barabar what? Capital T. All these 4 quantities are at t barabar what? Capital T. Now we have to determine these 4 quantities. So I'll draw the diagram here. Fine. See, at time 0 S1 is fired from here. This is x-axis. Point of position is O. X-axis horizontal direction containing the plane of motion. Y-axis is the vertical line in the plane of motion of the 2 shells. S1 is fired from here at time 0. At t block capital T, S1 is somewhere here. At t block capital T, S2 is fired from here. At a speed v0 at an angle theta 2. So this is the situation at t block capital T. At t block capital T, time 0 S1 was fired from here. O. As time passes by at t equal to capital T, S1 is here. At t block capital T, S2 is just fired from here. v0 speed at theta 2 angle. So horizontal separation between these 2 shells at time capital T, that is x1. Vertical separation between 2 shells is y1. Alright. Now how to find this x1? Tell me. Y1 is just the vertical displacement of S1 with respect to ground in the time interval 0 to capital T. So Y1 will be found from the laws of projectile motion, ut plus half at square in vertical direction. So V0 sin theta 1 into T minus half gt square, that is Y1. So what is x1? x1 is the horizontal separation between these 2 shells at t block capital T, or it is the horizontal displacement of S1 with respect to ground in 0 to capital T. So that is again constant because the horizontal speed of S1 is constant in projectile motion. The x1 will be speed into time, speed along x-axis, that is V0 cos theta 1 into T. These 2 quantities have been determined. Now we have to determine u relative y and u relative x. For that, again, these are quantities at t block capital T. At t bra capital T, velocity of S1 with respect to ground has two components, a horizontal component which is same as it was initially, V naught cos theta 1, and a vertical component which is again from V by u plus at in vertical direction, V naught sin theta 1 minus gt. So these are the two velocity components of S1 at time t, and this is the velocity of S2 with respect to ground at t bra capital T. But we have to determine u relative y and u relative x. So u relative y is the y component of relative velocity of S2 with respect to S1 at t bra capital T, and this is the x component. For that now we are observing S2 from S1. So we determine u relative. That is the relative velocity of S2 with respect to S1 at t bra capital T. That is just u2g minus u1g. u2g is nothing but this. So this will write as u2g plus minus of what? u1g. You write in this way. Or u2g is what? This is u2g. V naught cos V naught at theta 2 angle. This is u2g. And u1g is what? These are the two components of u1g. Now to find u relative, we reverse these two and add factorial to this. We reverse these two and add this. So we draw it separate diagram. V naught, okay, theta 2. And we reverse these two components. Reversing this meaning reversing the two components of u1. So this will be reversed. And this vertical will also be reversed. And this will have two components, this component and this component. So now we can find u relative x. That is the V naught cos theta 2 minus V naught cos theta 1. Not this one is this. V naught cos theta 2 minus V naught cos theta 1. Because with respect to S1, S2 is moving in this way. They don't need to collide now. So its x component of u relative should be rightward direction. So V naught cos theta 2 minus V naught cos theta 1. So V naught cos theta 2 minus V naught cos theta 1. And what about u relative y? Y component of relative velocity of S2 with respect to S1 at t bra capital T. Now y component will be y component of this V naught sin theta 2 minus this. Not this minus this, because in 0 to t to t1 with respect to S1, S2 is coming like this. So y component should be in upward direction. So V naught sin theta 2 should be more than this. So u relative y will be V naught sin theta 2 minus V naught sin theta 1 minus gt. Okay. So all the quantities have been fully determined. All we have to do is to put in that, substitute in that formula and solve it. Then you will get the answer. I'll grab this fine. So all the quantities have been determined fully. You can see. I'll grab this. So we substitute in that formula y1 by x1 V naught sin theta 1 into t minus gt square by 2 by V naught cos theta 1 into what? T. U relative y by u relative x. V naught sin theta 2 minus V naught sin theta 1 plus gt on simplifying it by V naught cos theta 2 minus cos theta 1. Okay, this V naught goes away. One capital T will go away here, common. Minus gt by 2 by cos theta 1 capital T cancels. V naught into sin theta 2 minus sin theta 1 plus gt by cos theta 2 minus what? Cos theta 1. Now cross multiply this. V naught sin theta 1 cos theta 2 minus V naught sin theta 1 cos theta 1 minus gt by 2 cos theta 2 minus cos theta 1 is equal to this into this V naught sin theta 2 cos theta 1 minus plus gt cos theta 1. Now you can see V naught sin theta 1 cos theta 1 and V naught sin theta 1 cos theta 1, they cancel out. This term goes away. Fine. So drop this, okay? So now simplify this, okay? So this becomes, this term will bring this side. So we get V naught sin theta 1 cos theta 2 minus cos theta 1 sin theta 2. Barabar. This is 2, okay? And GT will bring this side. GT cos theta 1 plus cos theta 2 by 2 minus half cos theta 1. So this becomes V naught sin theta minus theta 2 GT. This becomes half cos theta 1 by 2 common, cos theta 1 plus cos theta 2. So on solving the problem, T becomes 2 V naught sin theta 1 minus theta 2 by G times cos theta 1 plus cos theta 2. This is therefore the required answer. Fine. So in this video, today's third video, this is. So this is 36th video, 36th session on relative velocity. Today's third video, this date third video. So phase B of phase 1 has been fully discussed. So you can't see 36 first. First you have to see 34th, then 35th, then 36th. Okay, in continuation you must see. Then this concept will be fully cleared. So if you go through these problems, then you will get a lot of confidence and speed and accuracy. And you will be able to solve more and more relative velocity problems as they appear in JEE Mains and Advanced. Fine. So in the next session, we'll carry out the phase 2 calculation of two-dimensional relative velocity collision problems. Okay. 36th, 37th session will take up. Okay, fine. So we now close it here. Fine. All right.